and welcome in, my party people. Welcome into part one for area and perimeter. So in today's lesson, what you can expect to learn really is going to involve the basics. And what I mean by that is everything that you need to know to really be confident as you begin the introduction to word problems. So number one, first things first that we have to learn here, it's really going to be understanding the formula for area and perimeter. So those are the two main things we're doing today. And we have three shapes that we're dealing with. We're going to be dealing with squares, rectangles, and triangles. So after we learn those formulas, then we're going to slowly start moving into how to work backwards. Because one of the biggest issues that people face isn't actually memorizing formulas or just plugging things in. It's knowing how to plug things in the right way, knowing what you know. Like, how do you know that the problem gave you area when they didn't actually say area? How do you know it's perimeter when they didn't actually say perimeter? So those are some of the big things that we're going to be tackling today. And then number three, spotting those keywords exactly like I just said, but then using that to fill in our formula and then solve. So there's a lot to be done today and in tomorrow's class. Going to be a ton of fun. So let's go ahead and get started with our first set of notes. So with that, I'm going to go ahead and put these notes right up here. There we go. I'm going to put these notes right up here. We're going to start off with a square, then move forward to a rectangle, then do a triangle. And I'm going to give you a nice 2-minute timer to take each of these pages' notes down. So you're going to see a little timer pop up on the bottom right side of the screen. Feel free to take your notes. And then as soon as you are done, just type ready so we can know that you're ready to move on. We're going to go ahead and go over these notes here. So my party people, we're dealing with a square, and I want to make sure that everything here makes sense before we move on to rectangles and triangles. So first things first, let me just go ahead and just draw a little square on the screen. Again, no need for assistance from technology. I can draw a perfect square as is. So everybody, number one, let me go ahead and actually start with the perimeter. So everybody, what do we know about the sides of a square? What do we know about the sides of a square? What do we know about them? Yeah, they're all the same, exactly. All the sides of a square are the same. So this is the same as that, it's the same as that, and is the same as that. So all four sides are the same. Now, another question, everybody. When we talk about the word perimeter, does that talk about the outside or does that talk about the inside of a shape? So is perimeter the distance outside or the space inside? Yeah, it's the distance outside, correct. It's the distance outside. Now, take a look at what this says here. It says 4 times side for perimeter. Again, be careful here. For perimeter, it says 4 times the side. Now, most of us might think, well, if we're finding perimeter, aren't we adding all the sides? And the answer is yes, absolutely. So take a look here. Everybody, if we add the same thing 4 times, if we say side plus side plus side plus side, like if we were to really add that all up, everybody, isn't it true? Isn't it true that if you add up the same thing 4 times, that it's the same thing as saying 4 times that thing? Isn't that true? If I add side by side by side by side, it's the same thing as just saying multiply the side times 4. Good. That's all you need to know. That's all you need to know about where this little shortcut for perimeter comes from. It's 4 times the side because all the sides are the same. That's it. That's all where that comes from. And that's it. Now, when it comes to area, my party people, area is the one that talks about the space inside. That's the space inside the shape. And so to do that, that is a 2-dimensional unit. And all that needs to be said about that is to find the measurement of the 2 dimensions, so the length and the width. In this case, they're both the same. They're both just side, but we will multiply to get the area. And you'll see that it's side times side or length times width. Again, the sides are the same, so that's why it just says side times side. Now, there's a lot more to really get comfortable with here, but we're not going to be able to get comfortable with it until we actually start doing practice problems. So for now, are we good to move forward on our notes for rectangles? So let's go ahead and get the timer up so we can go ahead and take these notes here. So the timer is going to start momentarily. We have, again, 2 minutes, and we're moving forward from there. All right, let's go ahead and go over these notes here. Let's make sure we have this down, again, at least in a conceptual sense, just, in our heads, before we actually start the practice. So my party people, let's go ahead and go over it here. When we are talking about a rectangle, let's draw this thing up right there. Perfect. And then let's talk about what we see. When we're talking about a rectangle, we're going to have 2 dimensions that we're dealing with. It's going to be the length and the width. Sometimes you might see it as the base and the height, but for today's class, just to keep it simple, we're going to be talking about the length and the width, just like that. Now, I'm going to start off again with the perimeter to help us really understand where all of this comes from. Because we can look at either of these formulas and look at this and say, Coach, what the heck are we looking at? Now, let's keep it simple. Pop quiz again, everybody. If we're talking about perimeter, how do we get perimeter again? Just, again, in layman's terms, in a basic phrase, not formulaic. It's really just going to be about the outside of the shape. If you've ever heard in movies, the classic phrase, secure the perimeter. That really means secure the outside, the bordering distance around your shape or property. So everybody, when we are talking about the perimeter of a rectangle, let's think about this. Help me out. Because I see that I wrote the length right here, and I wrote the width over here. Can somebody tell me what I should mark this side as? What should I mark that as? Yep, that's gonna be length, absolutely. So we can go ahead and grab that and put it right there. Again, the opposite sides of a rectangle, they're gonna be the same. They're going to be the same. Same thing over here. The width is also gonna be listed right over here. Everybody, yes or no, do you agree with that? Perfect, sounds good. Now, let's go ahead here and again, understand where this formula comes from, where either of these really come from. Everybody, when we find the perimeter, we're adding up all the sides on the outside. We're just adding up the outside. So everybody, help me out. If I were to go ahead and take a look at either of these formulas, notice that it's 2 times length plus width, or 2 times the length plus 2 times the width. So here, if we look at this, it's saying that there's 2 of the lengths and 2 of the widths. Everybody, do we see that here? Do we see 2 of the lengths and 2 of the widths if we were to add all the way around? Is that what we see? Absolutely is, right? Absolutely is. So I want you to take a look at these formulas, not as something that you have to memorize, but as something that you should aim to understand. Because if you understand that a rectangle has 4 sides, so 2 lengths and 2 widths, then reading this formula, double the length, so 2 of these, plus double the width, plus 2 of those, it should make sense, at least on a mathematical level, that yeah, that makes sense. We have 2 lengths and 2 widths, add them together, and that's where that formula comes from. So does that help anybody out in terms of, again, just understanding how these formulas come together? Right on. And if we're asking, hey, how is this going to help me in word problems? I promise you it will. But we have to be patient while we get there. Now, lastly, the other part here is area right there. And like I said, just like with squares right over here, we have the idea that we are going to be multiplying the dimensions. So this is the horizontal and vertical dimensions, so side times side. That's where that comes from right over here. If we take a look at rectangles, we have a length and a width, multiply those together, and that's how we get the area. So the area is equal to the length times width. So with that, there is page number 2. After page number 3 for triangles, that's it. We're getting started straight with the practice problems so we can really flex our skills and then see where we get uncomfortable so we can really target that. So are we ready to move forward to triangles? Perfect. Sounds good. So let's go ahead and move it over and let's go ahead and have a conversation about triangles. So when it comes to triangles, we have two ideas here. Now, the first one, just like I have been starting with, is the perimeter. So allow me to go ahead and draw a triangle out. We have a couple of different ways that we can see triangles. One could be like a right triangle. So this is one way. Another way could be something like an equilateral or isosceles triangle. We can also have those weird looking ones like this, if this will even take as a shape. Probably won't. Let me go ahead and just do this a little better there. There we go. So these are all the different ways triangles can, not all of them, but just some of the ways that triangles can be shown. Now, my party people, notice again that there's different ways to show them. So when it comes to perimeter, we're just going to stick to the very general way. The very general way is going to be just add up all the sides. So we can call it A plus B plus C, where if we were to say, we have side A, side B, side C, or A, B, C, or A, B, C. As you can tell, I'm being very loose with it, right? Very loose. I'm just saying add up all the sides to get the perimeter. My party people, is that simple enough before we move forward to area? Again, perimeter just means add them all up. Add up all the sides, and that's it. Excellent. Now, area is going to be a very good one to really look at because not everybody knows where the formula actually comes from. So long story short, where this right here, this formula comes from, is simply this. We take the base times the height, so we could say something to the effect of, let me zoom on in over here, the base times the height, like that. But the reason that we divide it by 2, the reason that we see divided by 2 is because, my party people, a triangle is half of the space that a rectangle would take up. So that's why the formula for the area of a triangle is half of the base times the height. So whether that's a revolutionary epiphany for you or not, this is something that you do want to recognize and understand. If in case you ever get nervous and forget the formula, you can remember that the formula for the area of a triangle is just half of a rectangle. So my party people, let me know in the chat box how much sense that makes on a scale of 1 to 10. And then we will move forward to our word problem practice. Again, the area of a triangle is just going to be base times height divided by 2. And it's very important to distinguish the base and the height correctly. The base is how much we have left to right, and then the height is up and down. Once you have both of those, multiply it together, cut it in half, and we're good. Alrighty. Okay, so I'm very interested to see how this is gonna all play out. So we're not done with all of our notes, but I am wholeheartedly ready to start with our practice. So let's start with our first example here, everybody. So no matter what we're doing, whether this is your first class or 50th class with me, thank you, Jaslyn, in the chat box, for sure. RTQ, read the question. Everybody, can you tell me in the chat box, what is it exactly that we want out of this problem? Tell me quickly, what is it that we want out of this one? Yeah, we want the area. So I don't care how easy or hard a problem might be, we always give ourselves the best chance of success by starting with the question sentence. What is its area? Right there. Now, there's an advantage that you have with this, everyone. There's an advantage. Anytime you see area, volume, surface area, circumference, those geometry specific words that make us really nervous really hard to fall asleep to? Well, there's an advantage in there. And the advantage is this. Anytime you're being asked for those, geometry specific words, the first question we want to ask ourselves is, what's the shape? Because there is a formula associated with it. Exactly, Keon. Right on, you've been paying attention. So once we see this, everyone, once we see that we want the area, we're going to ask the area of what? What is the shape that we're dealing with here, my party people? Oh yeah, we're dealing with a square. We're dealing with a square. Notice that it says a square has a side length of 7 inches. So boom, right there, we know we're dealing with a square and we're looking for area. Help me out, everybody. Is there a formula for the area of a square? Absolutely is. Write it down. Go ahead. Hit me in the chat box. What is the formula for the area of a square? And if you're watching this as a recording, go ahead. Say it out loud. Yeah, it's going to be the side squared, or another way of writing it is the side times side. So we can say side times side, and boom. Now, all we need to get that area that we're looking for is going to be the side. That's what we need. My party people, whether you're nervous or confident, do you notice that, hey, we have a specific formula for this, and we now see all we need to plug in to get what we're looking for? Do we see that? To get the area of the square, we just need to plug in the side. Right on. That's all we need. So remember, geometry problems give you that advantage. They give you the advantage of formulas. So here, I can clearly see that if I just know what the side is, I can plug it in and I'm good. My party people, do they reveal what the side length is in the information? They absolutely do. Absolutely do. What do they say? It's 7 inches. A square has a side length of 7 inches. So right there, we have it clear as day. So everybody, let's go ahead, plug and chug, and we're done. Yes, it can feel that simple. I know the problems are going to get tougher with harder numbers, but it's really about how to use the formula. 7 inches times 7 inches. What's that going to give us, everybody? Now, there are 2 correct answers here. One is going to be 49, but the real, actual, true correct answer is going to be 49 what? 49 what? Yeah, I'm looking at the chat box being flooded right now with inches, 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 inches. I'm going to tell you right now, you're wrong. We are wrong. It is not inches. Whenever we are calculating area, my party people, area is a 2-dimensional unit. Yeah, so it's going to be square inches. Exactly. It's going to be square inches. You can write it like this, inches squared, or you can say square inches. Either way works, but this is really, really, really important. And why? Simply this. My party people, does every problem ever, do they always tell you explicitly if you're dealing with area or dealing with perimeter? Do they always explicitly say the perimeter is this, the area is that? Or do they sometimes use keywords or code words or implication to kind of tell you without telling you that that's what you're dealing with? Yeah. So my party people, if you were to run into a problem that said, hey, this square can cover 49 square inches, you know you're dealing with area because it's a square unit. Let me write this down here for you at the bottom left corner, right over here. So our perimeter is just going to be regular units. Regular units because it's just distance. It's just distance. Adding up all the sides, so that's just the distance. When it comes to area, everybody, you're going to see that always, and I mean always, 100% of the time, be shown as square units. And then, just for, blank and giggles, we're going to write in volume. Everybody, how many dimensions is volume? How many dimensions is volume? Isaiah, appreciate it. Yes, cubed. That's a 3-dimensional unit. So units cubed. So this right here, my party people, this is what you should be reviewing beyond the formulas, beyond mindlessly practicing. We have to understand what we're looking at. So if a problem is telling you, hey, how many square feet of grass or sod do you need to cover this garden? Even though they didn't say area, they told you you're looking for area because they said how many square feet. So it's all in the wording along with the formula to really prove that success. My party people, how are we feeling about what I just said? Is that easy enough to follow along with? Perimeter, regular units. Area, square units like square feet, square centimeters, square miles. Volume is cubic units, 3 dimensions, 3-dimensional unit. And that'll be cubic inches, cubic feet, etc. Right on. Right on. And also I want to shout out the participation in this class so far. This is great. Right on. So with that, let's go ahead here and keep it moving forward here in 2, 1. Now let's take a look at this next problem. So my party people, immediately tell me in the chat box, what are we looking for? What are we looking for? All right, so what is it going to be, everybody? What is it that we are looking for? Yeah, instantly they say perimeter. Instantly we see it right here. What is its perimeter? Now, everybody, pop quiz again. Give me a really quick phrase. What does perimeter mean? What are we doing? What are we doing? Adding what? Adding what? Adding all the sides. Exactly. That's really what needs to pop up in your head, everybody. The moment you know that you're being asked to find something purely geometric, you have got to get your head turned around on the formula, on the process, and then you're going to pick apart the information for what you need to perform that formula. So with that, we're looking for the perimeter. We want to know what shape. That's a square right there. So the formula for the perimeter of a square, there's 2 ways to write it. One is going to be 4 times the side, or we could add up all 4 sides. So everybody, if we're dealing with this square over here, if it felt like working for that one time, there we go. So if we have 5 inches on each side and we're multiplying that by 4, what is our perimeter going to be? Yeah, that's going to be 20. But 20 what, everybody? 20 what? You know I like playing this game. What are the units? 20 inches. Is it inches squared or just inches? Which one is it, everybody? Inches squared or just inches? Yep, just going to be inches. Just going to be inches because we're just adding up all the sides. So 5 times 4 is 20, and we're just adding up all the sides, so it's just still gonna be inches. Great job so far on that one. That was a very good job on that one. Now, let's go ahead and keep pushing here. I'll give you 5 seconds to finish taking your screenshot of your notes, but we're gonna jump straight into the next one. So again, the first thing you wanna turn your attention to is the goal of the question sentence. Because remember, there is no point in trying to take the notes on the information if you have no idea what the end goal is. Taking notes before you know why you're taking notes, it's just like mindlessly writing things down. So let's not be mindless, let's be mindful. 3, 2, 1, instantly tell me, what are we looking for, everybody? What is it that we are looking for? Hit me with a phrase or a word. What are we looking for? There we go. So I'm seeing that some of us work through that real-time anxiety. So I see some of us instantly saw perimeter and wrote perimeter down. That happens a lot when we're taking the actual test, right? You know, that heartbeat is racing. You're just looking for the first thing you see for comfort, and then you just go with it. But this is where it's so important to really stay grounded. Notice here what it says. It says, what is the length of one side? All right, my party people, do we see that? Do we see now that what we're looking for is the length of one side? Right on. Again, this is always going to be found in the question sentence. The who, what, when, where, how many, which of the following. You know those question action words? That's where you want to turn your attention to. So we want to know the length of one of the sides. Okay, cool. Sounds good. All right. Now, everybody, let's be real. Are we working forward or working backwards here? Yeah, we're working backwards. Notice how we're not looking for area or we're not looking for perimeter. We're now looking for one of the sides. So, everybody, this is going to be your soft/medium introduction into working backwards. How to stay calm, cool, and collected to get this done. So we want to know the length of one side. Okay, cool. Let's ask some more questions here, though. Side of what, everybody? What kind of shape are we dealing with? What kind of a shape are we dealing with? Oh, yeah, we're dealing with a square. Okay, dealing with a square. Now, everybody, what information do we have about this square? What information do we have about this square? Oh, we have it's 32 inches. What do you mean it? Be specific. Be specific. If you're trying to teach yourself, you have got to speak as if you're teaching somebody else. So 32 inches, what is that? What does that mean? Yeah, perimeter. Awesome. Let's go ahead and highlight that. The perimeter of a square is 32 inches. So, my party people, let me write that down here on the side. We have perimeter, 32 inches. Now, this is how you're going to be able to take care of every problem. Don't memorize what I'm saying. I want you to really take in what I'm saying. So, everybody, give me a quick yes or no in the chat box. Wait for me to ask the question. Wait for me to ask. But number one, we are looking for the length of a square, correct? Good. We're looking for the length of a square. Also, number two, is it true that we have the perimeter of that same exact square? Correct. Awesome. Question number three. This is the big one. This is the big one that you want to learn how to ask yourself consistently. The question is there a formula that connects the length and the perimeter of a square? Is the length and perimeter connected in some way? Okay, y'all are flooding the chat box saying yes. Now give me the formula. What's the formula that connects the length and the perimeter of a square? Write it down. Yes, 4 times the side, but more specifically, it's going to be the perimeter. The perimeter equals 4 times the side. That is going to be our saving grace here, my party people. That is our saving grace. Let me move this square over to the side a little bit. But this right here, this is our saving grace. How do I know? Watch and learn, everyone. We have the perimeter. We're looking for the side. That's all we need. Because if we have the perimeter and we're looking for the side, it's not working forward. It's working backwards. Because watch. Everybody, what am I replacing the perimeter with again? Yeah, I'm replacing it with 32. It says it right here. The perimeter is 32. So I'm going to replace the perimeter with 32. Look at what's going to happen here. Look at the ease that we can find ourselves in, because now we see, let me zoom on in. Now I see that to get the perimeter, we do 4 times the side. So if we want to work backwards, what's the opposite of multiplication, everybody? Oh yeah, the opposite of multiplying by 4 is dividing by 4. So whenever we're working backwards to find, whenever we're doing the length or the width or the side length, if we're just trying to find that, we are indeed working backwards and we'll do the opposite operation. So here we'll divide by 4 on both sides. Notice how it cancels here on the right side. And we'll just end up with the side length equals 32 divided by 4, which would be 8. And given that it's just a side length and we were dealing with inches, it'll just be 8 inches. But there we go, everybody. Hopefully that wasn't too too overbearing in terms of that first look of working backwards. I'll let y'all let me know in the chat box. How do we feel? Good, bad, in between about just working backwards? And more importantly, that question that I asked you to think about. How to ask, hey, how do we connect what I want and what I have? In this case, booyah, we have a formula. And all we did was plug it in, see what we got, and do our thing. Right on. Elijah, to answer your question, how do you do the dividing and multiplying on both sides? So Elijah, we always want to set our formula up, ask ourselves, what are we looking for? And we ask ourselves, are we working forward or backwards? In this case, given that we already have the perimeter, we're going to work backwards to get the side by itself. We got to get that 4 out of the way. So it's going to be working backwards, dividing by 4 in this case. So it's really about looking at, am I working forward, multiplying to get the perimeter? Or am I working backwards, dividing to come back down to the side? So those are the questions you want to ask yourself. Are we ready for another one here? Perfect. All right, sounds good. Let's go ahead and give this next one a shot. So first things first, everybody, immediately what you need to do is tell me, what are we looking for? What's the goal of the problem? Hit me. What is the goal? Right on. We are looking for the perimeter. Right on. We have that right there. Let's highlight that. What is the perimeter? So is anybody here thinking of muscle memory and instantly writing down perimeter equals 4 times the side. Is anybody here doing that immediately? 4 times the side, muscle memory, woohoo. Well, welcome into your daily segment of Getting Got with Coach Anderson. So that's not what you want to do. Remember, we want to make no assumptions. We want to make no assumptions at all. We have to make sure that we go through the progression. Here's what I mean. If I'm going through this, I see it says, what is its perimeter? Everybody, what did I tell you? Whenever you have a strictly geometric word like area or perimeter or volume, we have to ask ourselves, what is the shape? What's the shape that we're dealing with here? Yeah, we're dealing with a rectangle. Look at this. Dealing with a rectangle. That makes that the wrong formula. We have the wrong formula. Can somebody give me one of the 2 correct formulas for me, please? Yeah, let me erase this over here while y'all give me the formula. Can someone give me the proper perimeter formula for a rectangle? Yeah, there's 2 ways to do it. 2 ways. We have number 1, it can be written as double the length plus double the width. Again, this is one way to write it. Or we can go ahead and say, let me just do this because I'm lazy. Let me just copy this over. And then let's say the other way to write it is double the length plus the width. And so I'm going to show you this problem solved with both of the formulas so you can truly understand that, yeah, this is going to work either way you go. It's really just going to be personal preference. But let's go ahead and show this. We have a little rectangle over here off to the right. And so everyone, do we have the length? And if so, give me the number and the units. Do we have the length? Yeah, we do. And that's going to be what? Correct, 8 inches. So let me take purple here. Length of 8 inches. So we're going to have 8 inches right there. And then, my party people, what is our width? Correct. We have a width of 5 inches. So we have 5 inches right there. All right. So let's go ahead and just generally talk about perimeter again, everybody. Generally speaking, for any shape, how do we find perimeter again? Yeah, generally speaking, for any shape, the way we find perimeter is just adding all the sides. Exactly. So let me do that in its raw form first, so I can really help you appreciate how these formulas over here help you save time. So everybody, can you agree with me before I continue? Can you agree with me that up here will be 8 inches, and then off to the left, we will have 5 inches? Correct, because those opposite sides of a rectangle, they are going to be the same. So that's all that is. Opposite sides are the same. That's all I went over there. Now, let's add everything up together, everyone. Let's do that. So help me out, everybody. What is 5 plus 8? What's that going to be? Yeah, 5 plus 8, that's 13. All right, let's add another 5. What's 13 plus 5, everybody? 13 plus 5 is going to be 18. Okay, cool. So we have 18 now. All right, everybody. What's 18 plus 8? What's the final one there? 18 plus 8, that's going to give us, 26. Sounds good. So notice what we just did. If we went ahead and just did it raw and said 5 inches plus 8 inches plus 5 inches plus 8 inches, that's going to equal 26 inches. Okay, so again, that's the raw way of doing it. Just adding up all the sides. Super straightforward, it works. But sometimes if you need to get it done faster, well, we have to know how that can be done. So let's take a look. If we take a look, if we do double the length plus double the width, let me show you how smooth this can be. Everybody, the length was 8. So what is double 8? If I multiply 8 by 2, what's that going to be? 16. That's pretty easy. Nice. Then, if we take a look at the width, that's 2 times 5, because the width is 5. What's that going to be? That's going to be 10. Thank you. Appreciate y'all. Very active today. So then we have 16 plus 10. What's that going to be? 26. Correct. And look at that. Same correct answer so far. My party people, do we agree that that first version of the formula works just as well as adding them all up bit by bit? Yeah, same exact formula, right? Same formula. It works just the same. Now let me show you over here. Where does this come from? Well, basically, the way that this comes in, here's what it actually looks like. I'm going to highlight this in, let me use what I haven't used yet. Let's just do blue. So I'm going to highlight and encase this in blue. So we have the length plus the width in blue. Everybody, if I were to multiply it by 2, this is what it looks like. This is what it looks like. Multiplying it by 2 to include the other length and the other width. And that's what that is. If you double the length and the width added together, length and width added together, double it, you cover all 4 sides. That's the thinking behind this version of the formula. But let me show you that it works out just the same. Watch this. Everybody help me out. The length is 8, the width is 5. What is 8 plus 5 going to be? Yeah, we said that earlier. That's going to be 13. So we have 2 times 13. What's 2 times 13 going to be, everybody? Yeah, hardest question of the day. I know. Yeah, that's going to be 26. So yet again, my party people, we are good. Notice that either formula works. Going the brute force method, just adding up every single side together, also works. Are we feeling any more comfortable than we were before using either of these formulas, my party people? Sweet. Yeah, and even if it's a bit by bit, little by little, I will take that every day of the week. Very important that we, appreciate and acknowledge those small, simple steps that we want to be taking. So, right on, everybody. I'll give you, again, a quick 5 seconds here to take a screenshot. And then we're going to move forward again to the next practice problem, where we're going to be working backwards from perimeter. And let's see if we got it. All right, here we go. Moving forward. So first things first, everybody, I want you to tell me immediately the goal of the problem. You might see area, you might see perimeter, but focus on the question sentence. Here we go. What is the goal? Excellent. Immediately. Yes. What is the width? So notice there's a lot less anxiety, much less anxiety, when we're focused on the goal and the controllables beyond that. If we're starting with the notes and then wondering what those notes are going to be used for, not going to feel good, not going to feel great. But when we focus on the goal, then let that lead us to the information we have, then taking the information we have, then making a plan. Oh, that's beautiful. So we're looking for the width here. My party people, what shape are we dealing with if they give us a shape? Correct, that's going to be rectangle. So we have the rectangle right there. So we can nice and confidently say that we're looking for the width of the rectangle. Again, it's always important to get that goal situated first. We want the width of the rectangle. And if you want to, when in doubt, draw it out. Sure, feel free. Draw a little rectangle right there. Okay. Now we know that the length is 8 inches. They give us that right there. Okay. It's gonna be 8 above and below. And then what else are we given, everybody? What other piece of information are we given that might help us out? Oh yeah, we're given the perimeter. We're given the perimeter, and that perimeter is 24 inches. So let's write that over here. Let me get green. Perimeter is 24 inches. So P equals 24 inches. All right. So this is the same question I'm going to ask that I've asked before. So let's just take a bit of a little bit of a log here to see what we have. So we're looking for the width of a rectangle. We have the length of the rectangle. We also have the perimeter of the rectangle. My party people, is there some way, somehow, some formula that can connect the width of a rectangle, the length of a rectangle, and the perimeter of a rectangle? Is there a formula that connects those 3 things as it pertains to a rectangle? Oh yeah. So now, properly, fully write out our formulas. Please and thank you. So this is what I'm talking about. This is where the confidence truly comes in, where you can ask those questions and the questions lead you to what you're doing. Not, oh, I memorized this question and I think we're supposed to do this. No, we want to be confident. Excellent, excellent, excellent. Yes, the formula that we're dealing with is the perimeter of a rectangle equals double the length plus double the width. And the other formula works just as well. Either one is totally fine. But notice, We have solidified the connection. We have solidified our plan. We have our formula that connects us to the width of the rectangle, exactly what we're looking for. So I'll highlight that right there, and I'll fill in the information that I have. Everybody quickly hit me. What is the perimeter that I'm given? Correct, 24. Next, what is the length that I am given? Correct, 8. And then we have everything else, 2 times the width. And I'll keep that in red right there. Everybody, is this solvable? Is this solvable? If we take a look at this, if we clean things up and move things around, is this solvable? Absolutely. Absolutely. Everybody, does this change at all if we were to make the length, instead of 8, making it 92? Does that change the process here? If we make the perimeter 168 and the length 96, does it change anything? Correct, it doesn't. It doesn't. You're still going to be multiplying these two things together to clean things up. Then you're going to get rid of it. Then you're going to get rid of the 2. You're going to do everything you need to get the width by itself. It can be small numbers. It can be decimals. It can be astronomically large numbers. Doesn't matter. If we're using this formula to find this piece of information, given the other pieces that we already have, it's the same process. So I hope y'all understand that I'm using the numbers that I'm using to help you get in rhythm, to help you get used to this. And then as class continues going on, we're going to throw a lot more fun. We're going to throw a lot more fun your way. Okay? So let's go ahead here and get this done. So here we go. Just ignore what I said. I'll cut that out of the recording later. So here we go. Everybody, 2 times 8. What is that going to be? Yeah, that's going to give us 16. So with that, 16 right there. 16 plus 2 times the width. And then that's going to equal 24 on that left side. All right, great. So with that, up next, what are we trying to do next? Isaiah, you must have misheard me. I did not say torture. I said fun all the way. Come on, let's get focused again. Yeah, so are we going to be dividing though? Are we sure? No, we're not going to be dividing quite yet. Not going to be dividing quite yet, everybody. Because let's think about it. I know a lot of us are looking at the width right over here and thinking, hey, coach, we got 2 times the width. I got to get rid of that 2 by dividing. You're totally correct. You're absolutely right about that. You just are wrong about the order. Here's what I mean. Notice that this is the equal sign. We still have the 16 sitting there doing absolutely nothing. So we need to get rid of the 16 first, and then we'll have this isolated so that we can get rid of the 2. So again, we will divide by the 2 at some point, but we got to get rid of everything else first. The 16 is what I'm talking about. So what that means, everybody, is this. We will subtract the 16 from both sides. And now, look at what we have. We'll be canceling out on the right side. Everyone, what's 24 minus 16? Yes, that's going to be 8. We're good there. So we'll write 8 equals this right here. 8 equals 2 times the width. So now that we have that, I obviously need a little more room. So let me just copy this over. Let me just copy that over right over there and just draw an arrow to let you know that I just copied it over. So now that we're here, everybody, what do? Jaslyn, excellent. Yeah, now we perform the opposite operation, which we still did over here. The opposite of a 16 sitting there is subtracting the 16. The opposite of the 2 multiplied there is dividing by 2. So we have that, divide by 2 on both sides, and we have 4 equals width. Now, I'll agree with y'all. The first time, even the second time, it might feel like a lot. Louis, I agree with you. Totally agree with you. But let me ask this question. For those of you who are feeling like, yo, working backwards, it feels like a lot. Can you admit, confidently, that it is possible? Yeah, and that's what I'm going for. Because remember, before, in the past, we might be looking at things like area, perimeter, mathematics, arithmetic reasoning. We might be looking at these things as impossible, given our current skill set. So the next goal from impossible in terms of your mindset needs to be possible. Because once it's possible, then we can make it easier. And as we make it easier, we can make it more fluid. And as we make it more fluid, we can then make it automatic. So there are steps we need to trust ourselves to take. one bit at a time. So just to review this one more time, and then we'll go ahead and actually check our work by using the actual rectangle, and then we'll move forward from there. So here's what happened, everybody. In this problem, we wanted to know what the width was. That's what we wrote down right here. The next thing we did was, hey, if I'm trying to find some specific geometric term like length, width, area, perimeter, I'm gonna ask myself what shape I'm dealing with. And that's where I saw perimeter of a rectangle, boom, right there. So we're dealing with the perimeter of a rectangle and we're looking for the width. That's where the formula for the perimeter of a rectangle came in, because it involves the perimeter right there, involves the perimeter, involves the length that we're given right there, and we're looking for the width. So all we had to do at this point was we had to plug in what we had for the perimeter, which is the 24, plug in what we had for the length, which was going to be 8, and then the only thing left to find out was that width. So we cleaned things up by doing 2 times 8 right there. Then we moved that 16 over by subtracting it on both sides, getting us 8 equals 2 times the width. And the last thing we did was the opposite of multiplying by 2, which was divide by 2. And that's how we got the 4. So that's just a step-by-step in that respect. And then the other respect I want to give you here is checking your work. So everybody, our answer was what again? What number did we get as our final answer? Yeah, we got 4. Exactly. So let me put in 4 inches for the width. Everybody, if we were to calculate the perimeter here, let's go ahead and do that. Everybody, what is 4 plus 8? What's that going to be? 4 plus 8 is going to be what? Yep, that's going to be 12. And then if we double that to show all 4 sides, what's 12 plus 12, or 12 times 2? 24 inches. Interesting. Everybody, what was the perimeter that the problem gave us? What was the perimeter that the problem gave us? Oh yeah, 24 inches. So we were able to verify with the number that we got as our final answer, we were able to verify, even if we were confused or uncertain, that yeah, that is the proper correct answer. We are good to go. Anybody here feeling better about that? Before we get on to the next one. Oh, for sure. Yeah. So I'm glad that the majority of us are feeling good. And if anybody here is still feeling like it's a little challenging, yeah, that's going to happen. That's absolutely going to happen. Remember that this test, this exam that we're preparing for, it's a competition and it's going to be challenging. And as long as we stay the course with that practice, that persistence, and that patience, we're going to make that progress. So let's move forward to the next one here. 3, 2, 1, hit me. What is the question that we're trying to solve here? What are we looking for? Oh yeah, we are looking for area, correct. But remember everybody, the moment that we are exposed to a hyper geometry word, length, width, perimeter, area, surface area, volume, circumference, those geometric specific words, we have to ask ourselves what shape, because that's going to help us figure out the formula that we'll use. So what's the shape that we're dealing with? That's going to be a rectangle. That's correct. It tells us right there. Absolutely. Absolutely. So we have a rectangle and we're looking for its area. So with that said, everybody, immediately now, exactly, Dante, immediately we want to spit out that formula. Spit out that formula instantly. What's that going to be? Yeah, that's going to be area equals the length times the width. So we have area equals length times width. So everybody, we are secure in the fact that, yeah, we're looking for area. We're looking for area of a rectangle, and this is the formula that we know we need to deal with. So from here, if I'm looking for the area of this rectangle, now the only thing I care about is what's the length, what's the width. Because if I can plug those in, then we can solve. Do y'all agree? If I knew what the length was and knew what the width was, we can go ahead, plug and chug, and we're all set. Yeah, that's exactly what we're trying to do. So what do we see? We have a length of 9 inches and a width of 4 inches. So all we got to do is plug those values in, and we're set. The length of 9, and then the width of 4 9 times 4, my party people, is going to give us what? Yeah, it's going to be 36. But help me out, everybody. 36 what? 36 what? Ooh, getting closer. But it's going to be 36 square inches. Inches squared or square inches, either way. But remember, again, I'm just trying to prepare you for these word problems that we're going to see in a bit. We've got to remember that area is a two-dimensional unit. Length and width multiplied together, giving you square units or square inches. So let's keep the pace going. We're moving at a very good pace so far. Let's keep it moving here. Next up, immediately, everybody, again, tell me what we're looking for and also tell me the shape. Go. So we are looking for what? Yeah, we're looking for the width and it's a rectangle. Yes. So again, this is the first step of every problem. Not any math, not any note taking, just analysis. What are we looking for? What do we have? Simple as that. So we have the width right here is what we're looking for, and it's a rectangle in terms of what we're dealing with. So I want the width of my rectangle. So if you're nervous about this problem, I got you. Step by step here. We see that, again, we're looking for the width of the rectangle. We are given the area of such a rectangle as 36 square inches, and we're given the length at 9 inches. The question is going to be, same as before. Everybody, is there some way to connect the area of a rectangle, its length, and its width? Is there a way to connect those ideas? Awesome. Give me that formula. What's the formula that connects those ideas? Oh yeah. Area equals length times width. Now I noticed that some folks, and I saw someone change their answer as well, they previously had double the length plus double the width. And incorrectly, that's the perimeter of the rectangle. But for those of you that wanted to say double the length plus double the width, but you now see that it's length times width, do you see why the analysis is so important? To help you stay rooted in your confidence? Yeah, way too important to just take that extra second or 2 or 3 just to make sure that you know what you want. I know I'm looking for the width. I have the area of the rectangle. I have the length. And again, I'm looking for the width. When it comes to rectangles, the formula that should come to mind is area equals length times width. That is our formula all the way. So with that said, let's go ahead and write our formula down and fill in what we have. Everybody, again, this is how straightforward it can be. Everybody, what is the area that they told us in the problem? Yeah, the area, we see it right here. The area of a rectangle is 36 square inches. So I'm going to take that at face value, 36 for the area. Next up, we are given the what again, everybody? We're given the length. What's the value for the length? Yep, that's going to be 9 inches. So we'll write that right over there. Then from there, my party people, we're looking for the width. So as we take a look at this formula that we've set up, do we have enough information plugged in to solve for the width? Do we have enough information? Oh yeah, we do. Oh yeah, we do. So when we take a look at what we have, this is what we want to ask ourselves. On the regular area formula, we multiply the length and the width to get the area. However, we already have the area. We're trying to work backwards to get the width. So we want to get rid of the 9 that was being multiplied. So the opposite of getting a 9 away that was being multiplied. There we go, Louis. So yeah, now to get rid of that 9 that's being multiplied, we will divide. That's where the division comes in, because we observe what's currently happening and do the opposite operation. And once we do that, nice and easy, that 9 is out the door. 36 divided by 9, my party people, is what? Yeah, that width is going to be 4 inches, and we are good. There's the width of our rectangle, and we are set. So that's what I mean when I say you have to know your formulas You have to be able to plug the correct numbers into the right places and then let the rest reveal itself. Let the rest tell you if you're multiplying, dividing, adding, subtracting. You have got to give yourself that time to see that through. So I'm loving seeing the confidence starting to raise in the chat box. Now let's go ahead and move it forward here to the next one. Let's go ahead and give it an extra 5 seconds to take a screenshot. Exactly, Louis. Yep. We're just plugging the right numbers into the right places. Exactly. All right, my party people. Instantly, I don't care how anxious we are about seeing something new. Tell me in the chat box, what is it that we are looking for? You got this. Yeah, we're looking for area. And then the follow-up, as soon as we see that geometric term, area of what, everybody? What shape? Oh, yeah. We're dealing with the area of a triangle. So instantly seeing that, there's a formula that we should be writing down. Hit me with that formula in the chat box, please. The area of a triangle is going to be, yes, the base times the height, but what are we forgetting? Base times the height divided by 2, or cutting it in half. Half of the base times the height, for sure. Now remember, that's another way of just writing it like this. Half of the base times the height. These are the same thing. Same thing. This is just easier to deal with when you're trying to solve an equation. I promise you it's so much easier to see it that way. So with that said, everybody, we have our goal, looking for the area of a triangle. So what that means is we need to know the base, we need to know the height. Everybody, what are my base and height respectively? What are the two numbers for the base and the height? Correct, the base is indeed 10. I see that right there. And my height is 6, exactly. So we have a base of 10 inches, a height of 6 inches. So let's go ahead and fill in those pieces. And that's it. And that's all we need to do. So here, the base is 10. The height is 6. Divide that by 2. 10 times 6 is going to be 60. Everybody, 60 divided by 2. I know, hardest question of the day. Yeah, and that's going to be 30. And because we're dealing with area, it's going to be 30. What are the units? Pop quiz. Yeah, 30 square inches. Again, it is an area that we're calculating. It is a two-dimensional unit. Absolutely. Absolutely. So this was the easier one. I think we all feel, even though there was a fraction, I'll agree. Yeah, even though there was a fraction, it's still as straightforward as plugging and chugging. Now, let me go ahead and show you the elephant in the room. If we had to not maybe work exactly forward with a fraction, let's see who can keep it together. So, I love it. I'm training y'all. Yes, height. We are looking for the height. I'm glad that y'all went with the instinct. Yes. So we say we're looking for the height. What shape? What shape? What shape? Dealing with a triangle. Absolutely. We're dealing with a triangle and we're looking for the height. Perfect. So, my party people, we don't know what formula we can use yet. I don't know yet. All I know is that I am trying to find the height of a triangle. That's all I know. So just take it slow. So height of triangle. Now, with that said, what information do we have, everybody? What information do we have? What are we being told about this triangle? Yeah, we're given the triangles, what again? Yeah, we're given the area and we're given the base. Exactly, we're given the area and we're given the base. So with that, we have the area of the triangle being 24 square inches. And then we have the base being 8 inches. So my party people, this is where, again, until this becomes automatic, until this is muscle memory, you have to ask yourself, what is the formula that connects the height of a triangle, the area of a triangle, and the base of the triangle? What's the formula that connects them together? Excellent job, Hunter. Yes, we are going to have the area equals the base times the height divided by 2. Again, you can also write half the base times the height. Both mean the same thing. But even if you know the formula and you can regurgitate it, that's all good and well. But the next question is, can we plug the right numbers in the right places? And then once we do that, can we actually solve? So we still got to be careful here. We got to be careful because we're looking not for the area, but for the height. So let's plug in what we know, everybody. What is the area that we're given? What is the area that we're given? Yeah, we're given the area as 24. So this right here in blue, that's what I'm going to replace with 24. Let me just make this a little smaller. Okay. So I'm going to plug in 24 right there, and then I'm going to continue plugging things in. Everybody, what was the base that I was given? Correct. The base that I'm given is 8 inches. Correct. So we have 8 inches as the base. We still have that 2 on the bottom. And again, we're multiplying by that height. Before I continue and before I get to the actual solving, everybody, are we good with the way that we plug things in? We plugged in 24 for the area because that's what the area was. We plugged in 8 for the base because that's what they told us the base was. And we leave the height as is because that's what we're trying to solve for. Excellent. Excellent. Now, is anybody sitting here just, pencils down, looking at this fraction saying, yeah, I'm waiting for coach to finish this for me. I'm waiting for coach to lead the way. This looks a little tough. I think it looks like I caught half the room. Okay. So I got you. So everybody finish the blank here, fill in the blank. Solving equations is the art of blank. 2 words. Solving equations is the art of Keon, my man, Zone. Yes, working backwards. Solving equations is the art of working backwards. So everybody, you tell me, what do we notice looking forward? Help me out here. What do we notice looking forward? What operation is between the 8 and the height? What operation do we see right here? Yeah, we see multiplication. We see multiplication. And then what operation do we see right here with the 2? What is the 2 doing? Yeah, that is division, exactly. That 2 that we see is division. So let me show you 2 ways to solve this problem so I can really reinforce the point that this is not as hard as we might believe. So let me just move this over here. We're going to do it again in a second. But let me just show you the longer way. So everybody, we're going to work backwards here. Everybody, what is the opposite of dividing by 2? Because we said, again, we see that it's division of 2. So what's the opposite of dividing by 2? Yeah, it's going to be multiplying by 2 on both sides. Bear with me here. Watch and learn. So I'm going to multiply by 2 on both sides. That's going to get rid of the 2 on the right side. And so that's going to give me still the 8 times the height. That's still going to be there. Everybody, what is 2 times 24? Correct. That's going to be 48. 2 times 24, that is 48. And then lastly, everybody, how do we get rid of that multiplication of 8? How do we get rid of that multiplication of 8? Yeah, we're going to divide by 8 on both sides. Exactly. So I'm going to divide by 8. And everybody, what is my height going to be? My height is going to end up being what? Yeah, it's going to end up being 6. Now, again, if you need that time to work on solving equations, if you're in the program, you know where to go to continue working on solving equations. But remember, it's all about working backwards. What we did was the opposite of dividing by 2. That's how we got rid of it. Then we did the opposite of multiplying by 8, which is dividing by 8. And that's how we work backwards. Now, if we feel like we're kind of sort of understanding this, let me go ahead and come on over here and invite you to think about things in a way that's actually going to make a lot of sense. My party people, real quick. We have an 8 in the numerator, 2 in the denominator. Can we simplify that? Can we simplify the 2? Oh, we absolutely can. Yeah, we absolutely can. So let me go ahead and do that for you. Everybody, what is 8 divided by 2? Yeah, that's going to be 4. If I divide the 2, we notice that this is going to turn into 4 times the height. All we did was simplify first. We simplified first. And once we simplified, everybody, we're going to divide by both sides. We're going to divide both sides by 4. And once we do that, everyone, what's 24 divided by 4? Cancels out on the right side, giving me the height equals 6 inches. And there we go. Same exact answer, 2 different ways of doing it. And as long as we understand how the root of the mathematics works, we're good. How solving equations works, we are good. Remembering that you can simplify fractions, we are good. So notice how all of this comes together. You can't say that you want to master word problems if you're not there with fractions, if you're not there with equations, if you're not there with these other ideas. It takes time, everybody. One day better, one day at a time, but it takes time. So does that make sense, my party people? Does this specific problem, working backwards with the triangle, make sense to you? Perfect, 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 perfect. So with that, let me go ahead. Perfect. So Adiel, saw your comment there. Yep, at the end, I'll go ahead and do that for you. I gotcha. So with that, we are now all done with the main examples. Now I want to test your ability to get these problems done. Now, here's how we're going to do this, everyone. Here's how we're going to do this. We are going to do this by giving you a 30-second timer. Again, 30 seconds. Here's what I expect in the 30 seconds. It's purely the analysis part. In tomorrow's or the next lesson's follow-up, we are going to work on the full 2.5 minutes for the question. But for right now, our main goal is simply going to be in 30 seconds, can you point out what we're looking for and then write out the formula that we're gonna need to use. Everybody got it? 30 seconds to write out what we're looking for and the formula that we will be using. Excellent. Sounds good. So with that said, let's go ahead and put a timer up for the very first question here. And 3, 2, 1, let's go. 30 seconds. Don't reveal your answer until the timer is up. All right, so let's go ahead and give this one a shot here. Let's dive on in. So correctly stated in the chat box, yes, we are looking for the perimeter. And some of y'all took it further and said we're looking for the perimeter of a rectangle. And the perimeter of a rectangle is going to be perimeter equals double the length and double the width added together. So notice how some of the answers were different. Some of us said length times width. I saw a couple folks say 4 times side. So notice how, although the answer is right there in front of you with your notes, do y'all understand the practice that is necessary to make this automatic? Yeah, it's going to take time. So again, give yourself that patience and grace. You got this. Here we go. So we're looking for the perimeter of the rectangle. So what I know instantly is if I had the length and the width, I'm good to go. If I had that length and I had my width, I'm good to go. And the great thing is I have the length and I have the width. I have everything I need. So I'm set. So here we go. My length is going to be 14. My width is going to be 6. And I'm just going to rewrite everything else around it. It was 2 times that length plus 2 times that width. Boom. So Vanessa, if we're looking for perimeter, we use the formula if it's of a rectangle. This is specific to a rectangle. And that's why we needed to know the shape for sure. So now that we know the shape, we can put out the formula. And now that we have the formula, we plugged everything in. Now that we plugged everything in, we're here to solve. So 2 times 14, that's going to be 28. 2 times 6, that's going to be 12. And now we have 28 plus 12, and we bring all that together, and that's going to be 40 centimeters. And there we go. And that's why the answer here is B, 40 centimeters. So I see in the chat box the question saying, hey, what's the easier way of memorizing the formulas? Well, think about it like this. Let's go ahead and take it way back to, let's say, if you went to college or let's say high school, let's say you're in school, your crush comes up to you and says, here's my phone number. What's the first thing you're going to do? Memorize it. Say it over and over and over again. If someone were to rip that paper with the number out of your hand, well, guess what? You lost it. So going over it again and again and again is going to help you memorize it, especially in practice. Using the formulas in practice is the fastest way to memorize them. So here we go, my party people. Next question coming up. And what I need you to do, same as last time, is immediately tell me what the question is telling you to find and what formula we need to use. So 3, 2, 1, let's go. So who here feels like this problem was way out of your league? Who feels like this one was out of your league? All right, let's prove it. It looks like a lot of y'all are saying that this one's out of your league. I beg to differ. I'm willing to bet, and I'm not a betting person. I'm willing to bet that y'all actually do understand this question, but it's possible that some of us may have been overwhelmed by the amount of words. We may have been overwhelmed by the different words that we see. We may have been overwhelmed by not being given perimeter or given area explicitly. Does that sound like some of us here? Does that sound like you? Yeah, look, I've been doing this for a while. I did this on purpose because I want to show you that you can actually do a problem like this very, and I'm not going to say easily because I don't want to disrespect anybody's, current status, but I can bet you that this can become straightforward if you look for the right things. So here we go. Number one is, what are we looking for, everybody? Tell me, in a short phrase or a word, what is this problem telling you to find? Yeah, we're looking for a side. We're looking for a side. Take a look right here. Using this information, determine the measure of the adjacent side. So right there, everybody, you didn't have to read all this to get that. So this is me showing you this is absolutely possible. Take it one step at a time. We are looking for the measure of the adjacent side. Can we all agree, with it being circled plain as day, that we are looking for a side? Okay, cool. That's step one. So there we go. I proved point one. Yes, you can at least figure out what you're looking for. So we're looking for the side. Now, up next, whenever I said, if we're looking for the length or the width or the area or the circumference or the perimeter, we got to know what shape we're dealing with. Everybody, what shape are we dealing with? And also, adjacent side means a connecting side. So for example, if we're talking about, and y'all say it here, that we're dealing with a rectangle. So if we're dealing with a rectangle, here's what this means, everybody. They tell us in this rectangle, one of the sides measures 15 meters. Okay, that means that this right here, 15 meters. If they're asking you for the adjacent side, that's the side next to it. That's what they're saying. So does that help anybody and relieve a little bit of pressure from anybody knowing that now? Oh, look at this. Okay, a lot more folks saying, oh, no, I get it. Yeah, I told you. You just have to be able to break it down bit by bit. Now, what's next? Everybody, think about it. We're looking for the side of this rectangle. We have the other side of the rectangle. That's certainly not enough. We're going to need something. Like, we don't know what formula to use yet, because when you ask yourself, hey, what formula connects the length and the width? Well, that could be perimeter. That could be area. That could be volume. I don't know. So this is where we're going to take a look at the information here. A community garden has been designed in a rectangular layout, fully cultivated over a total of 240 square meters. Everybody, even though they didn't say it, what did they just give you with the 240 square meters? This is a test to see who was paying attention earlier in class. Yeah, they just gave you the area. Why was that again, everybody? Why is that the area again? Yes, the square units, the square meters. I'm a proud teacher right now. Oh man, if I was a crying person, I might shed a tear. So yes, right here, we see that it's 240 square meters. Remember what I said earlier? Square units, that is area. So that's what they gave us. Area equals 240 square meters. That's how you know that it's not perimeter, and you can guarantee that it's area. So now that you guarantee that, you have the area of the rectangle, the length of the rectangle, and you're looking for the other side, which you can call the width. Everybody, can we set up a formula to connect those things? Can we set up a formula to connect those ideas? Oh, yeah. Oh, yes. So with that said, the area of a rectangle is the length times the width. And if we plug in everything we have, look at how easy it can feel. 240 is the area equals the length, which is 15, times that missing width. Everybody, even if we don't know what the calculation will result in, what is the calculation we need to do to finish this problem? What is the calculation? Yes, division. We just need to divide both sides by the 15, and that's it. We're done. We can practice calculating quickly. We can practice all of that for sure. But yeah, that's how we would get it done. And that's where your confidence should really start rising, because it's all about how we are going to get it done before we actually do the calculation. Who here feels confident now that if they solve this problem again on the actual test, that they would instantly recognize square units as area and then, oh, adjacent side, that's the other side? So this is where I'm talking from. Yeah, this is where I'm coming from when I say that you just have to give yourself that patience, because we can turn a problem that looked ridiculous into doable, into possible, and then we'll get automatic. It takes time. So here, when we divide by 15 on both sides, the answer to that, my party people, is going to be 16. If we divide, yes, we did work backwards here because, again, we had the area already given to us. We had the length given to us, and we just needed to find the width. So yes, we did work backwards. And yes, Keon, square units are also surface area, but we're not dealing with a 3D object. It's a flat two-dimensional object, so that's just regular area. So with that, here we go. Let me just finish this off here, my party people. Dividing by 15 on both sides. If we do the math, that'll be the width equals 16 meters. So we can do some long division on that, some mental math, either way. I just want to give you that final answer because the most important part here was really the setup, understanding the area and understanding how to plug things in. So with that said, everybody, there it is. That is part one, the introduction to the basics. In tomorrow's class, we are going to be really kicking it up into high gear, where we're going to be doing more and more problems like we just did just now, where I won't be giving you the area or perimeter explicitly. I'm going to infer it. I'm going to imply the area and perimeter, and your job is going to be to figure that out, get the formula going, and solve the problem. That's what it's going to be about, my party people. I'm really excited to have y'all in tomorrow's class.